Hello again. In this video, we are going to continue with our problem session. We reached exercise 4. Let's read it together. So, in a cylindrical resistor traversed by direct current, 6 times 10 to the power 18 electrons cross its section per minute. So, we have, let me draw here, what do we have? Choose a nice color. So we have a cylindrical resistor and the number of electrons that pass through this resistor is N. Let me just write it in the right places. N equals to 6 times 10 to the power 18 electrons. Okay? And the time, and that's per 1 minute. So the time is 1 minute. I want this 1 minute in the SI unit, that's in second. 1 minute is 60 seconds. So the number of electrons that passes each 60 seconds is 6 times 10 to the power 18 electrons. The first question, part A, they're asking us, calculate the current in the wire. Let's calculate the current in this specific wire. We know that I equals to Q over the time T, and that is but we don't have the Q, we don't have the quantity of charge, we have the number of electrons. And from the previous lesson we know that the quantity of charge is the number of electrons multiplied by E, the elementary charge. So Q equals N times E, so now I equals N times E over the time T. That is 6 times 10 to the power 18, and E is 1.6 times 10 to the power minus 19 divided by the time T, which is 60 seconds. We are using the SI unit, and that is basically 0.016 ampere. We can write it in a nicer way. 0.016 times 1,000, that would be in the milliampere. So 0.016 ampere, that is 16 milliamperes. Okay, that's part A. Now let's move to part B. In part B, they're asking us, you measure the current with an ammeter whose dial has 100 divisions. So the maximum number of divisions, or the divisions in the dial, is 100 divisions. So we have 100 division in this dial, and we can use either the scale of 20 milliampere, 1 ampere, and 10 ampere. So the current that we have is 16 milliampere. The closest to the 16 and still greater than 16 is 20 milliampere. So what we're going to use is, let me change the color. So we're going to say here we use the 20 milliampere scale, because, let me write 20 in a better way. 20 milliampere scale. Why? Because here it's greater than 16 and close to 16 milliampere. Okay, the question is, what scale should we use? So we already stated that we should use a 20 milliampere scale. And to which division does the needle point? So let's calculate to which division does the needle point. So we have 100 division. When that's the maximum number of division, 100 division of the full dial represents the full scale, which is 20 milliampere, right? How many divisions will the needle point to if we have 16 milliamperes? Are you understanding what we did here? So the full dial, which is 100 division, means the full scale 20 milliampere. How many divisions will the needle point to if the current that we're trying to measure is 16 milliampere? So let's do this rule here. So the number of divisions, or the deviation of the needle, equals to 16 times 100 divided by 20. Okay, that is basically 80 divisions. So this ammeter will point at 80 divisions, and these 8 divisions will represent the 16 milliampere. Okay, that's number 4. Now let's move to number 5. Here's number 5. So in number 5 we have the circuit of figure 3.30, and we have to calculate I5, I6 and I1. Let's just write down where's I1, I2 and I3 and everything. Let's use this blue color here. So I1 is up here. We don't know what's I1. I2 is in this branch, and this is I4 in this branch, and I4 is 2 milliampere. In this other branch we have I6. We don't know what I6 is. And in this branch here, the one coming out is I2, which is 4 milliampere. In this branch here it's I5. We do not know what's I5. In this branch coming out it's I3, and we know it's 6 milliampere. It's given. Okay, first we need to get I5. First we get I5. Okay, so we know that the current coming out of this junction here is 4 milliampere, and current I4 and I5 are going into the junction. So we know that the summation of this current here, I4 and I5, will give us I2. If I4 is 2 milliampere and I2 is 4 milliampere, so 2 milliampere and something give us 4 milliampere. Of course, 2 plus 2 is 4, so I5 would be 4 minus 2, which is 2 milliampere. Okay, let's write it down here. Let us zoom in. I5 equals to I2 minus I4, which is 4 milliampere minus 2 milliampere. That's simply 2 milliamperes. Okay, so we just calculated I5. Now let's deduce I6. Okay, let's choose another color. So I6 is here. There is this current coming in, and I3 and I5 are coming out. So what's exactly I6? We know that I3 is 6, I5 is 2. So the summation of both of these currents is going to give us I6. Okay? So I6 this is number 5, right? This is number 5. So let us write down I6 is basically I5 plus I3. I5 is 2 milliampere, I3 is 6 milliampere. Together they make 8 milliampere. Okay, let me show you again. So this current and this current together make I3. So this current here and this current here, I'm sorry, I did a mistake. So what I mean is that these two currents together make the current coming in. So the current coming in, I6, is divided into these two branches, 6 milliampere and 2 milliampere. So I6 is basically 8 milliampere. Okay, now let's use a different color, green. We need to find I1. We already have I6, we have I4. The current I1 branches into these two currents here, 2 and 8. So I1 is simply I2 plus I6. I2 is 2, not I2, I'm sorry, I4. I4 plus I6, I4 is 2 milliampere, I6 is 8 milliampere. That gives us 10 milliampere. So 10 milliampere. Okay. So we just calculate what they want. They wanted I5, I6, and I1. We just got I5, I6, and I1. Now let's move to number 6. Number 6 is here. Let's read it together. In the circuit of figure 3.31. So this is figure 3.31. We have the lamps are identical. So all these lamps here and here and here and here and here, all of them are identical lamps. And the ammeter indicates, let me write it down. The ammeter indicates 0.12 ampere. Okay, let me write it here. So 0.12 ampere. This is what the ammeter reads. They're asking us to determine the current and the direction in each of the lamps. Let us start writing. So what is shown that this is plus, this is minus. Know that the current starts, or it is generated, or the direction of the current is out of the positive pole of the battery by convention. So that's I. Let's first specify the direction. It's gonna pass through this here and it's gonna divide into 2. Then it's gonna recollect here. It's gonna divide into 3, and then it's gonna recollect in this point, and then it's gonna continue through the current, through the ammeter, into the battery again. Okay, that's the direction. Let's choose another color to find the value of each current. Okay, the current that's supplied by the generator is the same current that's supplied here, the same current that's gonna go back into the ammeter, because into the generator and out of the generator is going to be the same. So the current I passing through L1 is 0.12 ampere. Okay, because they're all in series. So the current, let me here, I1 equals to I equals to the current passing through the ammeter, which is 0.12 ampere. Okay, now the current passing through L2 and L3 is actually this current divided into 2, because we have two identical lamps. So I2 is equal to I3 equal to I1 divided by 2. So 0.12, so 0.12 divided by 2 is simply 0.06 ampere. Okay, now the one that's recollected here is 0.06 plus 0. So the recollected here is 0.06 plus 0.06 is again 0.12 milliampere, ampere or milliampere? Ampere, 0.12 ampere. Again, the current here is going to divide into 3. So instead of dividing by 2, we're going to divide by 3. And we have 3 identical currents because we have 3 identical lamps. So I 4 equal to I 5 equal to I 6 equals to I1 or I divided by 3. 0.12 divided by 3 is simply 0.04 ampere. Okay, and again these three currents here are going to be recollected, and we have 0.12 again, and that's verified again by the ammeter up here. Okay, so by this we just finished the problems in the book. In the next session, if it was in class, it's gonna be that we're gonna solve some exercises from the guide. Okay, if you have any questions, please ask me, and I'm gonna send a PDF where all these exercises are